we were supposed to write on our periodic table. So we got to know what the different groups are called. Okay, so yesterday what we spent a little bit of time doing was we reviewed where our cutoffs were for the different types of elements. So we have our non-metals over here on the right-hand side. Our metalloids, we made a stair steps. There you go. And we went all the way down to polonium, and everything that was touching was basically a metalloid, not including aluminum and not including astatine. I did say that I was going to follow up on this. This one is a noble gas, so I looked it up. It is a noble gas, so it is a non-metal. Our tennessine is going to be a halogen, so it's also going to be that non-metal. And then this one says it has similar properties to polonium, so I'm going to assume it's not a metalloid, but it's going to be a metal. Okay, so that's what this is. So metal, non-metal, non-metal. Okay, that's kind of what we got for those three. I said I would tell you guys that. All right, then over here on the left-hand side, we had all of our metals. Okay, we had a lot of those. And then we had to color hydrogen with our non-metal. Okay, all right, and then that was kind of what we did yesterday. So if you missed yesterday, that's what the coloring is. I do have color pencils. You can do it later. All right, so we're going to write down a couple facts that we need to know. So first thing is, does anybody remember what the up, down, or the columns are called? What? Not rows. No. Okay, these are your groups. So write this on the left-hand side of your paper. But groups. They're also known as families. So if you think about it, okay, your family, you have a lot of qualities like them, right? You're pretty similar if you live in the same household, kind of thing, right? You're pretty similar to those people. That's your family, okay? Or if you don't live with them, then you recognize some things are still the same with your family, right? So so we've got that, groups and families. I'm going to go ahead and add one other thing. They also have the same valence electrons. That's going to be important today. Okay, same valence electrons. Does anybody remember what valence electrons are? I say remember, it's not that we talked about it. It would have been something from like middle school that you possibly talked about. Does anybody remember what a valence electron is with the Bohr model? Yep, the outer ring. So like, for example, the Bohr model, there's 2 electrons on the outside ring, so it has 2 valence electrons, right? So everybody in the same group will have the same number of valence electrons, okay? So let's handle that right now, and then we're going to come back to this, and we're going to write one other thing, okay? So we're going to put a number, we're going to put numbers above things. I'm going to circle some of them. Hold on, let me hide this. There we go. I'm going to circle some of them, and the other ones we're not going to circle. The ones that are being circled are those valence electrons, okay? So this is group 1. So you can put a 1, and you're going to circle that, okay? 1, meaning they all have 1 valence electron, okay? 1 valence electron. Group 2, you can circle that as well. Group 2 all has 2 valence electrons. So for example, what I had just shown you with this Bohr model is possibly something from group 2, or it is something from group 2 for sure, okay? All right, so take the second to now turn your paper sideways, because we're going to name these. Okay, group 1 is known as your alkali metals. And group 2 is known as your alkaline earth metals. Okay, now I know you can't see it very well because of the lines and stuff, so I will go ahead and write it. So in case you can't see those, group 1 is called your alkali metals, and then your group 2 is alkaline earth metals. Okay, so if you needed help with the spelling, there you go. Have you guys ever heard of alkaline batteries? No? Those are your normal batteries, like your AA's and stuff like that are usually your alkaline batteries. So kind of normal, it's because it involves metals, different like columns of metals, and they transfer electrons, and that's how we get our power. That's just seeing if you guys recognize the word. All right, so alkaline metals, alkaline earth metals. Yesterday, students were asking, do you need to memorize them? Yes, you need to know which one is alkaline metals. You need to know which one is alkaline earth metals, okay? So make sure you know group 1, shorter name, group 2, longer name, okay? That's kind of how we do it. 2 words versus 1 word. That's another way students have memorized it. All right, is everybody good to move on? You're all good? Okay, cool. Awesome. So now what I want you to do, you're flipping your paper back to normal. We're going to write these, but I don't want you to circle any of these, okay? So we're going to do 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Now, the reason we're not circling any of those is because those do not represent valence electrons. Okay, we're going to see why when we get to electron configuration, which is how they're mapped out. We're going to see why these aren't the valence electrons. These are your multivalent cations, which means they can be a different number of cations, or valence electrons technically. Okay, so we'll talk about that later, but don't circle any of those. These are just the group numbers or the family numbers. Now they don't get fancy names, so you can just kind of make a little bracket. These are known as your transition metals. Transition metals. Sorry. Try bubbles and see if it helps a little. Okay. All good? You got that written down? Okay, cool. So looking to the next one, so where boron is, we're going to go ahead and put 13. Once you write the number 13, circle the number 3. So kind of spread out the 2 numbers just so you know that. So it is group number 13, and it has how many valence electrons according to what we've been circling? It has 3, exactly, okay? And this one we're going to do 14, circle the 4, 15, circle the 5, 16, circle the 6, 17, circle that 7, and 18, circle the 8. Okay, so this tells you the group numbers. So there are 18 families on this periodic table. But remember that when you get over here, it's not 17 valence electrons, it's only 7. Yes?
So is it just like keep it in order? That's why it keeps going 13, 14, 15.
Yes. Yep. So that's the point of this chapter is periodicity. So we're going to see then once we get here, then it starts over. It starts over. It all has to do with the valence electrons. Yep. So your valence electrons are only guaranteed on your main group elements. That's the ones that kind of stick up, right? So these first 2 and those last ones, the only ones that we circled are the only guarantees of valence electrons. The other ones we got to figure out later when we get to bonding. All right. All right. Let's put the names for these. All right, so turn your paper sideways again with me. So the 2 that you have to worry about memorizing are going to be 17 and 18 because they have fancy names. Then I'll tell you the other easy ones. All right, so group 17, does anybody remember that one? Does anybody remember 18? They have a full shell. They're a something gas. Nobody? Oh, man. All right, that's okay. All right. So 17 are known as your halogens. Halogens. And then group 18 is known as your noble gases. Does that ring a bell for anybody? Noble gases? That one usually people kind of remember. All right, so I can write it out again so you can see it. So this is next to 17, this is next to 18. Okay. So missing one in their outer shell, full outer shell. 8 is the maximum that you can have on a Bohr model level. Okay. So I would say these 4 are the ones that you really have to bother trying to remember, because they're not the easy names that I'm going to show you right now. All right, so those are the ones that you really want to try to get memorized as soon as possible. Okay. Halogens are super reactive, alkali metals are super reactive. So I would put a star next to this one, and I would put a star next to your alkali metals, because those guys will react pretty quickly. They're kind of our most dangerous ones that we've got, because they react so quickly.
Isn't that like the further away from you get, like here and here, those are like the most reactive?
Yeah, actually, it's the ones that are right next to your noble gases, because everybody's trying to be a noble gas. They're trying to get 8 valence electrons on the outside. So these only need 1, so they're going to react as quick as possible to get that one. These guys need to lose 1, so they're going to react as quick as possible to lose it. So yep, so the ones that are, if you were to turn your periodic table into a circle, they're the ones right next to your noble gas. Okay. That's a great question. All right, you guys, so these over here are groups 13, 14, 15, 16. This is how boring their names are. Group 13 is known as your boron family. So what do you guys think 14 is going to be called? The carbon family. I'm just going to put carbon fam. 15 is going to be your nitrogen fam. And then 16 is your oxygen family. Okay? So again, it's just going with who's at the top of the list, or at the top of the periodic table. So boron, carbon, nitrogen, oxygen. So as long as you write boron, and you can write just like an arrow going across, and if you can figure that out on your notes, then that's fine. You don't want to write them all. You know, it gets a little crowded. Okay. All right. Once you have that, flip your page over, because I'm going to have you write something else down. I'm not going to talk it through, but this had to do with your drag and drop activity from yesterday. So everybody's kind of been writing down the answers just to have it in your journal. So once I put this up here, you're going to be writing down what's on the back of this, on the back of your paper. And then I want everybody to get it taped into their journal, whether you tape it so that you can flip it, or you tape it and you write it underneath it in your journal. Okay, so everybody get your journal out. I'm going to flip this over so that you guys can see the back. I'm going to give you guys about 4 minutes to kind of get this written down. Okay.